Hello everyone, this is Dr. Song. So welcome to my YouTube video. I just published my previous session of the week 3 part 3. So we will continue to study about variability range, outliers, Skewness, and kurtosis. So again, this video, this course is based on the 3 courses I got from the University of Ottawa. So this is the references. And then now let's talk about the quartile. So I said that we use the quartile is the most frequently in the statistics. So that means that it's 25%, 50%, and 75%. So you divide the whole data with the 4 portions. So 24, 5%, 50, 20, 75, and 100. So we call that 25th first portion is the first quartile. That is a Q1. And then 50, that's the second quartile Q2. 75 is a third quartile Q3. So we divide by the quartiles. And then when we want to know about the range, is a minimum and the maximum, you can provide the Q1 and then Q3. So Q3 minus Q1, we will call that interquartile range. So this distance is between the 25th and then 75th. So this is less affected by the extreme scores. So maybe you can imagine that when you have the different the scores here, this is Q1 and this is Q2 and this is a Q3. Yeah. So when some people ask about what is the range from the minimum and the maximum value, instead of the from the here and then here, you will obtain this difference between the Q3 and Q1, that interquartile range that can reflect the better central tendency. Why? Because it's this part and then this part, it can be very much distant from the mean score Q2. So it can be that it's very low and then it's very high. At least you can eliminate this risk of the influenced by the high score, the low score. So Q3 minus Q1 is very appropriate the mean value. So that is a range value. Sorry, range value. So the maximum will be the Q3, minimum Q1. That is interquartile range. So dispersion is talking about the range. So what is the maximum and the minimum? So is here you can see the scores, and the maximum is 52 and then the minimum is 18. So that is a range of the 24. So normally when you do this is we call we have that I will show you the what was our rule. I will show you that. Yeah. So maximum minus the minimum and then plus 1. That is the range. So some scholars, they consider that this is correct. But here, what we have, that is in the different way. So you have the 52 minus 18 is 24. Other scholars, they will put the 1 here, and then there will be a 25. But anyway, that is depending on the scholar. So that is the range from the maximum and the minimum. So interquartile range, you will, as I told you, that is Q3, and then you divide minus Q1, and then that will be the 20. So instead of 52 minus 18, then that was the 24. Now the range changes, that is a 20. So this is less influenced by the extreme scores. Now, what is the box plot and whisker plot? That is, in fact, showing that about these 3 quartile is a Q1, Q2, Q3, and also that is showing what is the limitation to consider extreme value or not. So that is related to also the outliers. So how you can decide the minimum value and then the most high value? That will be a maximum Q3. So that is 3 quartile. Q3 plus 1.25 and then the multiply by interquartile range. Yeah, interquartile range, that is here 20. Yeah. So when you obtain that, that will be in the most high. When you have the box plot, and then that will be the maximum how you can put the limitation. And then when you have the Q3, so minimum is a Q3 minus 3, and then there is a minus 1.5 and QIQR, that is interquartile range. That will be in the down, okay, in the down. And then this is in the general outlier, outliers, but it's not extreme. When you want to say that the extreme outliers, you will put a 3. So it will be like a 3 and then 3 here. That is a plus 3, and then there is a minus 3, yeah. And then they are the extreme scores. But if they are between 1.5 and then 1.5 here, and then there will be outliers, but another extreme. So you can see that is a Q3 that is in the box plot. You have that box here, and then the first line that is a Q3, and then the bottom line is a Q1, and then you can put the multiply by 1.5. That is the maximum, and then it's a minimum. Okay, so when that becomes the plus minus 3, it's beyond that line, and you will consider that is extreme outliers. And then normally they are treated by the asterisk, and then you can find that in your SPSS when you generate the box plot, and then they will be considered like a point, and then with the asterisk, that is the outliers. So like that, yeah. So that is a 95 percentile, and then this is a 5 percentile, yeah. So that is the 1.5, yeah. That is the general amount of the maximum scores and the minimum scores. And then here you can see that is a maximum, that limitation, and a maximum. This is a maximum, and then this is the minimum ranges. So if the scores are inside of that, you can consider that they are outliers, but it's not like extreme. And now you can see that scores are over than this the maximum and the minimum line. So in that case, you will consider that they are outliers. Okay, yeah. So this is a box plot. And now let's see about the quiz. What is the interquartile range for these scores? So you have to divide by 4 portion. First portion is here, and third portion is here. So 26 minus 10 is 16. So the range, interquartile range here, that is a 16. And then we are talking about outliers. So we just saw that from the box plot. Those scores is over the maximum and the minimum line. We call that they are outliers. And then they are extreme scores. So outlier cases, if there are outliers, median and the mode are preferable over the mean. This mean is not a good representation of the data due to the outliers. Yeah. So you can see that the outliers, they are influencing the central tendency. So it's less credible. So that's why outliers we have to deal with very carefully. So you can see the box plot is a maximum is here, minimum is here, and then this is a first quartile Q1, median is a Q2, third quartile is a Q3, and then you decided that by the formula I showed you, you can settle what is the maximum and the minimum. So you can see that, and then this score is outside beyond the maximum, so we call that is outliers. So outliers, a score very different from the rest of the data. High score, outlier pushes the mean up. Yeah, that is normal because of the outlier that influence the mean value. Low score also that influence the mean value in the opposite way. So usually use the cutoff plus minus 3. That is about the extreme outliers. And then you can see that here, the one example uh, about that outliers. So outliers is influencing the mean value, but also that is influencing the UR form of the data. So that is called the skewness and the kurtosis. So skewness is about how the data is in the bell curve here. There should be something like that. But in fact, that can be like this, or it can be like this. So when you have the form like this, they are positively skewed, and then this is like this, they are negatively skewed. So this is about the skewness. So when you have the outliers that is forcibly influencing the mean value, and then you can see that they are not like the bell curve in the center. That is very much like this. They are positively skewed, so they are very much in the left side negative values. So what is the outliers? How you can deal with the outliers? So you can remove the case. So when you have the one case like that, you can remove this, and then you don't have any outlier. So this is the first option. And the second option, transform the data. So if you have many outliers, you can do the scale the each score, and then you can transform the your data. So that can improve the outliers and then the influence. And the third option, this is what I use most, that is a windorization. That means that if you have the plus minus 3 outlier Z scores, you can make that with the what is the most close value with the Z score. So for instance, if you have the score with the plus 3, and then just before the another score that is a plus 2.8, and then you will obtain that with the, you will not write this, you will put that is 2.8. So you will windorize with the most close value instead of the taking that plus 3 because there is an outlier. So you can reduce the impact of your outlier scores. Now, let's see about the kurtosis. That is about not the skewness, but about how much high the graph and how much they are flat. So when it's a flat, it's a platykurtic, and then the other opposite position is a leptokurtic. So this means that if there is a mean value, they are very close to the mean value. It's a less variability. And then when that is very much flat, that means that they are very deviated from the mean, so the variability is very high. You can say by the kurtosis if the variability is the high or low. And the skewness, I told you, when it's the graph is the left side, you can say the positively skewed. When it's the graph is the right side, you can say the negatively skewed. So let's see. You have measured the age of the student in the classroom and realized that the variable is highly positively skewed. That means that your graph is like very much in the left side. So that is positively skewed. So the scores are clustering near the bottom, means that they are the young age students. So you can have an interpretation of your skewness. When you obtain the by SPSS, you will see that there is a minus 1.5 and then minus 0.5. That is moderately skewed. But they are a bit skewed in the left or right side. And then smaller than 1.5, that is highly skewed. And then greater than 1.5, that is also positively skewed, and then the negatively skewed. So that is negatively, and this is positively. And then kurtosis, that is also it's the same rule, is minus 1.5 and minus 1.0, 1.5. That is like a negatively kurtosis, and then it's a positively kurtosis. Negatively kurtosis means that it's a flat, and then positively kurtosis means that it's a very leptokurtic. That means that. So that is you can see that is when it's a normally distributed graph is like that. But when you have the outliers, and then you will have the skewness like that kind of form, and then you will see also central tendency is affected. So they are different mode, median, mean. When it's normally distributed, mode and the median and the mean, they have the same position. But if they are skewed, they have the different numbers. So here you can see that that is a like you can obtain that you divide by the 4, and then Q1 is 10, median is 19, Q3 30, and then so IQR interquartile range 30 minus 10, you can obtain the 20. And then these are the what was the box present in this chart is a interquartile range. So that is the answer. And then how many outliers can you identify in this variable? You can see that there are 2, and this is 3. Okay, so until here. Thank you so much for the second session of the week 3. And then we can see the next time with the summer laboratory. Thank you so much. See you next time.